Hey, next part on moles. Hopefully you watched the one on volume and conversion of liters, things like that. Now we're moving on to molecules and atoms. So I'm going to use the screen back here. I'm going to point your attention to our island diagram that we did before. Now, there is a third or a fourth island, a third bridge that we have. And remember, the mole specifically was 6.02 times 10 to the 23rd particles of anything. So our third island is a particle island. We're going to put it down here. And I'm going to put atoms in here, or particles. Could also be molecules. They're all going to fit into this little thing here. So particles, atoms, or molecules. And there's a bridge for this one. And the bridge that we need, or the number we need to get across this, is that 6.02 times 10 to the 23rd. Okay, big number. So the math for this is going to require that we do some exponents and stuff like that. But for this little video, we're going to focus on just this part. So going from moles to atoms, or atoms to moles. So we got a few examples right here. All right, and so we will go, let me take this, create some space here so we can. All right, so here in this question, it says, how many molecules are there in 2.00 moles of ammonia? All right, so just like we did with the other ones, we're going to write what we know. Okay, we know that we have 2.00 moles of ammonia. Okay, ammonia is NH3. I don't expect you to know that, but NH3, any of these that we do as real examples or we do in worksheets, I'll make sure that you know what they are. But 2.00 moles of ammonia, and just like before, we write the one underneath it. Okay, now in this case, we're going from moles. The question says how many molecules, so we're going to molecules. All right, molecules, atoms, particles, all the same in these examples. So usually I just abbreviate molecules with cules. I don't want to write the whole word molecule. So put that on there. That's what we're solving for. And we have moles here, so we're going to put moles down in the bottom. Okay, so hopefully you see that whether we're solving for mass or volume or liters, the conversion process is the same. So you got to know which bridge you're crossing. Okay, so if I'm going from moles to molecules, I have to cross this bridge. The number we need to get across the bridge, and this line represents that bridge, is 6.02 times 10 to the 23rd. Okay, it's called Avogadro's number. We put 1 down here because in order to see moles, we can put a 1. Now all I have to do is multiply by 2. 2 times 6.02 times 10 to the 23rd. So here's the process I use on my calculator. You're going to have to be familiar with whatever kind of calculator you have. Okay. So 2 times 6.02 times 10. And then on my calculator, I use this little button right here, this little caret button. So I'll hit that button, and it gives me that little exponent symbol there. And then I can write 10 to the 23rd. So see, I have this. Okay. Then just hit enter, and it multiplies it, and I get 1.204 times 10 to the 24th molecules. Okay, so if I'm doing sig figs though, there's 3 there, there's 3 there, so this should be 1.20 times 10 to the 24th molecules of ammonia NH3. Okay, let's try another one. All right, so this one, we have 0.5 moles of chlorine. So write what you know. 0.50 moles of chlorine. Chlorine is Cl. We put that over 1. Now, so I'm here. I'm at Mole Island. I'm going to go to atoms, okay, or molecules. So I'm going to put cules right here, just like we did on the last one. Cules there, and moles down here. Okay, so 1 mole, 6.02 times 10 to the 23rd again. And I just have to multiply half, or 0.5. 0.5 times 6.02 times 10. So I get to all this part again. There's that. I guess you can see it. And then hit the little caret button. And then I can put in 23, and it's got the exponent there. And hit enter. And I get the answer, 3.01. All right. Let's do one more of these, and then we'll take our next step. So I'm going to go up here where we have, say a line, I'm going to go here. So let's do this one. I have 1.806 times 10 to the 24th molecules of bromine, and we're trying to find out how many moles in this case. So we're doing number 9 here, this one. Okay, you have this paper, you can take a look at this. So 1.806 cules of bromine, put that over 1. So now I'm sitting at this island, and I have to go 2 moles. Which times 10 to the 24th. Okay, and then here I have moles on the top, and I have molecules on the bottom, because I'm solving for moles here. So I'm going to put a 1 anywhere I have moles, and then here I go 6.02 times 10 to the 23rd. That's what I need to get across this bridge. Now, mathematically speaking, I'm just dividing these two, but you got to be careful on this one. So let me show you the process. I go 1.806 times 10, hit the caret just like we did on the other one, 10 to the 24th. So I get that, and I hit enter, just because then my calculator will rearrange it for me. So it just rewrites it. Okay, oops, I think I wrote it in wrong, so let me start with 1. Forgot the decimal. 10 to the 24th. So I got that. My calculator writes it as an exponent. Now, this is where you have to be careful, because if you're going to divide by this number, which you're going to, you have to put it in parentheses. So I got this. Okay, and I hit the divide. So we do that. And now I'm going to put the parentheses and go 6.02 times 10 caret 23 and close the parentheses. See, I write it in parentheses there, because that way the calculator reads it correctly. You can do it however you want. You probably know how to use your calculator better than I do. But if I hit enter, now it gives me the answer, and I have 3 times 10 to the 23rd. Oh, I think I did something wrong. Okay, so when I do that, 3, the answer is 3. I have 3 moles of bromine. Okay, and whenever you're solving for moles, when given these big numbers, those numbers should be small. Okay, we will do some more of those, but that's it for moles to molecules for now.